Now, welcome to Class TV. I am myself Aliwi Tosin. This is Elasticity Part 4. Now we are taking Young Modulus. Now, before we define Young Modulus, there are some prerequisites that need to be understood. There are some things that need to be understood. Firstly, let's talk about what you call tensile stress of an elastic material. What is tensile stress? Tensile stress of an elastic material is the ratio of force to area. Ratio of force of the elastic material to the cross-sectional area of the elastic material. What I'm referring to? Refer to this place as the cross-sectional area. I will refer to this F as the force exerted on the elastic material. So we said that tensile stress is ratio of force to area, and it is given. It is measured in Newton per meter square. So the unit for tensile stress is what? Newton per meter square. It can also be written this way. Newton per meter square. That's the unit for what? Tensile stress. So we need to know what tensile stress is. We said is what? Force, the ratio of force to what? To area. Now, we also need to talk about what we call what? Tensile strain. Tensile strain. What is tensile strain? The tensile strain of an elastic material is the ratio of what? Extension of the elastic material to original length. Ratio of what? Extension to what? Original length. Extension to original length of the elastic material. That is what? Tensile. That's a tensile strain. Our extension, this is our extension E, increase in this what? The length, and the original length, this is what? L. So we can say that what? Our tensile strain now can be written as what? E over L, where E is the extension and L. Now, looking at this, when we said tensile stress is what? Force over area. We said the unit is measured in what? In Newton per meter square. But in case of tensile strain does not have unit. Why? Extension is a length measured in what? Meter. Also, original length also is a length measured in what? Meter. So when M cancels M, then we have what? Nothing. As what? As we have 1. So which is what? Which means there is no what? There is no unit. So have it in your brain that what? Tensile strain has no unit. Tensile strain has no what? Unit. Now, this being known now, we can now talk about what you call what? Young modulus. What is Young modulus? Young modulus can be defined as the ratio of tensile stress to tensile strain. Young modulus can be defined as the ratio of what? Tensile stress to tensile strain. Young modulus, can we denote it as this, is the ratio of what? Tensile stress to tensile what? Strain. Now, recall that we said our tensile stress is given as what? Force over area divided by tensile strain is what? Extension over what? Original length. Which means we can say that what? Our Young modulus can be given as, when we change decision to times L goes up, E comes down, so we have L over what? E. Which means that what? We are having FL over what? Over AE as our Young modulus. So that's the formula of finding what? Young modulus. That's force times original length over what? Cross-sectional area times what? Times the extension. So with this now, what is the unit for finding, what's the unit of what? Of Young modulus. Now let's derive the unit for Young modulus then now. Our F is what? Is measured in Newton. Our L is what? Is measured in meters. Our A is meter square area. Our E is also what? Meter. So we say this cancels this now. So which means that so you're having what? Newton meter square. So Young modulus is measured in what? In Newton meter square. Just the same measurement that tensile stress has. Tensile stress has Newton per meter square as its unit. Tensile strain does not have any unit, while Young modulus has what? Newton per meter square as its unit. Now, at this point, let me bring our attention to something. At this point, let me bring our attention to something at this point. Now, while I was taking Hooke's law, I said that what Hooke's law states that provided the elastic limit of an elastic material is not exceeded, the extension E of the elastic material is directly proportional to what original length of is directly proportional to what the applied force. Directly proportional to applied force or load. Now, what am I saying here? Another way that we can also state Hooke's law is this. We can also say that Hooke's law state that provided the elastic limit of an elastic material is not exceeded, provided the elastic limit, I explained to us what elastic limit is, of an elastic material is not exceeded. Now, if an elastic material is not exceeded, now we say that what tensile stress is directly proportional to tensile strain. Tensile stress is directly proportional to tensile strain. So that is what Hooke's law, which is another way by which you can state your Hooke's law. We said what provided the elastic limit of an elastic material is not exceeded, tensile stress is directly proportional to what tensile strain. So I think as far as Young modulus is concerned, what we have left is to take some questions on the topic Young modulus. Okay, so on this note we come to the end of this topic, but we are left with calculations. But the knowledge needed for us to attempt any calculation in this topic has been acquired. So in our next video we'll be taking calculations. As far as this topic elasticity is concerned. Now we've been able to talk about how to state Hooke's law. We've been able to talk about being able to verify Hooke's law. We've also been able to discuss elastic energy, also the concepts of Young modulus and tensile stress, tensile strain. So now in our next video we take questions and examples on this topic. I read myself Aliwi Tosin. We meet in our next class. Thank you.